Welcome to the video on calculating determinants by hand. Before we start, I want to tell you where we are in the bigger picture of math. There's this giant topic in mathematics called matrix algebra. I've drawn it as some random blob here. And within that topic, there's sort of a subtopic of what are called determinants. And within that subtopic, there's this teeny little piece that is referring to calculating determinants by hand, and that's what this video is about. The reason I'm giving you this big picture here for the moment is just sort of a warning, because this video is only about calculating the determinant, and you're going to learn this without any larger context of where you are, what or why you're doing it. So this video gets very step-by-step, very procedural, and almost seems strange and leaves the viewer wondering, why on earth is he doing that? Well, without being in a matrix algebra class, which, if you're watching this video, you probably aren't in one, without being in a college-level matrix algebra class, you really don't see the bigger picture. And so when things in this video seem very strange, just sort of roll with it and understand that you're not getting the full context. So first, let's start with, what does a determinant look like? Well, here's an example of a determinant. A determinant is basically a bunch of numbers with these two straight lines surrounding them. These straight lines sort of look like absolute value bars. They're not really what they are, but that's what they look like. And it turns out that this entire determinant has a value of -39. I worked that out on scratch paper, and I'll show you how to do that later. We call this determinant a 3x3 because it has 3 rows and 3 columns. Here's another determinant, which we would call a 2x2 because it has 2 rows and 2 columns. And that determinant has a value of 16. I'll show you in this video how we figure that. Determinants can be larger. They can be 4x4, 5x5, 6x6, and so on, as long as they have the same number of rows and columns. We can assign a determinant value to that array of numbers, also known as a matrix. The purpose of this video is to give you the calculation tools on how to turn these 4 numbers into 1, or these 9 numbers into 1, which is called the determinant of the array of numbers. What this video is not about is, what on earth does any of that mean or have to do with anything else in mathematics? That is a hugely interesting question, and one has to take a course in matrix algebra to really understand the full meaning and have an appreciation for what a determinant is. In this video, you'll get calculation techniques and, unfortunately, nothing more. That being said, let's look at our first actual determinant calculation problem. Let's start by looking at a 2x2 determinant. Here's an example. Here's how you calculate a 2x2 determinant. First, you multiply these two numbers, the 8 times the 5, or whatever numbers are in those two positions exactly. 8 times 5 is 40 in this case. Then you multiply the other two numbers, or whatever numbers are in exactly those two positions. In this case, 2 times 3 is 6. Once you've done those two multiplication problems, you subtract. 40 minus 6 is 34, and that's the answer. Here's the work one more time for you to take a look at. There are a lot of good questions that arise here. Why do we multiply those numbers specifically? Why do we subtract at all? Those are questions that that are answered in the larger context of matrix algebra, and we're in the middle of this video, we're just not there. So you'll have to just accept that this is the procedure for calculating a 2x2 determinant. What does it all mean? It means a lot, but what does it mean in this video? Absolutely nothing. We're focusing solely on the calculation aspect. One thing worth pointing out as a reminder is that a determinant, whether it's 2x2, 3x3, 4x4, or so on, evaluates to one single number. This determinant has a value of 34. Now let's turn our attention to the much more difficult 3x3 determinant. Here's an example. All right, this is a long process, so bear with me. What we're going to do to compute a 3x3 determinant is we're going to take the first column. First column has 3 numbers in it, obviously, and for each one of those numbers, we're going to compute what's called the associated minor determinant, or just the minor. The definition is there. We'll get to that in a minute. It's easier to see what that definition means through the examples. Well, we're going to compute the minor of 2, then the minor of 5, and then the minor of 3. In other words, we're going to work our way down the first column, computing this so-called minor for each one of those numbers in the first column. Let's start with the minor of 2. I'll show you what that looks like. As you can see in the matrix, I've highlighted all the numbers that are in the minor of 2, meaning the 1, 7, 8, and -6. Those are the 4 numbers that share neither a row nor a column with 2. In some sense, you can see I grayed out the row and column containing the 2, and that left me with 4 numbers. Those 4 numbers form the minor associated with 2. But that in and of itself is a 2x2 determinant. So how do we calculate a 2x2 determinant? Well, that's what we just did in the prior problem. This algebra represents the technique that we learned in the prior problem. I'll pause while you convince yourself that's what we just learned. And I did the algebra on that on my scratch paper, and I got -62. Okay, so I have the minor associated with 2. I just want to remind you that we're working our way down the first column, and now we're going to do the minor associated with 5. So I'm going to gray out any number that's in the same row or column as 5, and that leaves me the 4 highlighted numbers. You might see them in red. And that's the minor of 5. So those 4 numbers, the -9, 4, 8, and -6, those 4 numbers form the minor of 5. And now I have to compute that 2x2 determinant. Well, that's again where you multiply the 2 diagonals and subtract, just like we learned a few moments ago. Here's the algebra. Convince yourself that that algebra is what we learned a few moments ago. I worked all that out on scratch paper using PEMDAS, and I got this. Just a reminder, look at our determinant near the top. We're working our way down the first column, and next we need to compute the minor of 3. So the minor of 3 is formed by all the numbers that share neither a row nor a column with 3, and you can see them highlighted there. Perhaps you see them in red. Here are the numbers that make up the minor of 3. I do that calculation, algebra on scratch paper, PEMDAS, and all of that leads to -67. Well, we're not done computing the determinant, but what we have done is we've computed a minor for every number in the first column. Now, we're moving on to our next phase. What we're going to do now is multiply each of the numbers in the first column, the 2, the 5, and the 3, by each of the results we got for their minors. I'll pause while you process that. Those are the 3 multiplication problems we're going to do. Again, I've multiplied each number in the first column by its minor. I haven't actually performed the multiplication yet, but I'm preparing to perform the multiplication of each number in the first column times the answer we got for its minor. Now, before I proceed, I'm getting close to the end. You're never going to believe what goes here. A minus. And right here, a plus. And why is there a minus in one of them and a plus in the other? That's just the rules. There's a very profound reason for that, but it's a reason that goes way beyond this video. So just put a minus where we put the minus and a plus where we put the plus. And all that's left now is to work out this algebra problem, which I've done right here. Now, before we conclude, it's worth mentioning that you notice how we used the first column and only the first column to perform this process? Well, we used all of the numbers, but we based all of our minors on the first column only. There are ways to do this by choosing the second column or the third column, or even by choosing a row instead and working our way across sideways. There are many ways to do it, but the process changes if you choose a different row or column, perhaps. So to avoid the process changing and going beyond things that you may not, into things that you may not know, always use the first column and do it exactly like I showed you here. It's important again to remember that determinants have a single value as their quote answer. And so here we've essentially condensed these 9 numbers into 1 with the determinant process. Now, that being said, before we conclude, it's worth mentioning that calculators will do determinants for you. But chances are, if you're watching this video, you're in a class that doesn't allow calculators. And so there's not much point in saying that calculators will do them. If you're here, you've chosen to be here because you need to calculate these by hand, and that's exactly how you do it. One more final comment. There are many, many other ways to compute the determinant of a 3 by 3. This is only one of them. If you YouTube 3 by 3 determinant, you'll probably get different variations, and you might even find something you like better. That concludes this lesson.